So let's solve the problem. We're going to begin by computing the equilibrium. And to do that, first we're going to look at the problem of the firm. So each firm does the following. Maximize over Q greater or equal than 0, PQ minus, let me take the parentheses out here, the total cost, which is 5Q plus 2EQ. And notice that E is taken as given. This is going to lead a solution using the standard methods, which is the quantity supplied by firm J is going to be equal by P minus 2E divided by 10. Adding over the 10 firms, we get the quantity supplied by the market, which is P minus 2E. Okay? Notice, by the way, that in equilibrium, as a side note, in equilibrium, the inverse demand function is Q plus 2E star. The inverse supply function, sorry. And this is a marginal private benefit that the firms are going to use to make the marginal private cost that the firms are going to use to make their decisions. Now, let's look at the equilibrium conditions. We know that in equilibrium, E star has to be equal to the quantity supplied. So this implies that the quantity supply in the market has to be equal to P minus 2, the quantity supply in the market, which implies that in equilibrium, the quantity supply in the market is equal to P divided by 3. Also, we know that in equilibrium, it has to be the case that the quantity supply in the market is equal to the quantity demand in the market, but this is equal to 1000 minus P. This is equal to P divided by 3, and together this implies that P star is equal to $750 per unit, and Q star is equal to 250 units. Let's continue with the solution. Now we're going to compute the optimality. And to do that, we need to start by looking at the marginal social benefit. But we know that that is going to be equal to the marginal private benefit plus the marginal damage. So this is going to be 1000 minus Q. This is equal to the marginal private benefit plus 4Q, which is equal to the marginal total damage. Remember that the total damage was 2Q squared, so this is just the derivative. Sorry, this is minus because it's a damage. So the total marginal social benefit is equal to 1000 minus 5Q. Now, what about the marginal social cost? We're going to start by looking at the total social cost, and we're going to do it by before. If we want to produce Q units, we're going to produce them by allocating them equally across all firms, given the nonlinearity on cost. So the total social cost is going to be 10 firms times the cost per firm, which is 5 Q over 10 square plus 2Q times Q over 10. And notice that this Q is just equal to the value of the externality. We are substituting, because when we're computing total social cost, we have to take that into account. And if you do the algebra, this is just equal to 5/2 of Q squared. This implies, taking the derivative, that the marginal social cost as a function of Q is just 5Q. And it follows that Q optimum solves marginal social benefit equals to marginal social cost, which implies that 1000 minus 5Q is equals to 5Q, which implies that Q optimal equals 100. So let's conclude by computing the deadweight loss. Now we know that marginal social cost is equal to 5Q. We know that marginal social benefit is equal to 1000 minus 5Q. We know that the optimal amount is at 100, but that the market generates an outcome of 250. So what is the deadweight loss? It's going to be this area here. And let's compute it. That deadweight loss is going to be equal to the integral from 100 to 250 of the area between these two curves, which is 5q minus 1000 minus 5q dq. And this is just equal, if you solve the integral, to 5q squared minus 1000q evaluated between 250 and 100, and this is equal to 112,500.